notes by writing your definition of the roots of a function there at the top. What do you think they are? If you can't totally remember, don't forget you have a book that has a glossary and an index. All right, but think about it, and what do you know about the roots of a function? Somebody tell me what a root is. It's the zero. It's zero, makes the equation true. Okay, so another word for it is zero. Let's see, where is it on a graph? If we have a graph that looks
is it in the middle?
Like this, it's the x what? X intercepts. So that is the x value when y equals 0, which is kind of what Kyla said. All right? It's the x value when y equals 0. Remember that. If at some point you end up taking pre-cal, calculus, any of that sort of stuff, whether it's high school or college or I don't know what else. Depends. Then roots are very important. They're kind of the basis of everything. So you've got to kind of remember this stuff. So the next part of today, we're learning a new word, or at least in this class it's a new word, and that is conjugates. Okay, you use that in Spanish class, but we're talking about something different here. Yeah. All right, so a conjugate, it's a number pairs, so it's a pair of numbers in this form. They could be imaginary, so a plus bi and a minus bi. The only difference between the two numbers is the sign in the middle. It has to be that way. So you can have the same a's, the same bi, so it's imaginary, but the plus and the minus are different. Got it? Okay, or you could have the same thing with these crazy square root ones. Okay, so the a is the same, the b's are the same, it's just the sign that's different. The sign in the middle. Okay, so those are conjugates, those two pairs. So we could say that a plus bi is the conjugate of a minus bi. That's kind of the way things are said. All right? Now, why are we learning this? Well, conjugates are really nice because if one of them is a root, then that automatically makes the other one a root. Okay, that's the conjugate rule. So if 3 minus 14i is a root, what is also a root? 3 plus 14i. The same thing with a different sign in the middle. All right, if negative square root 11 is a root, what is also a root? Positive square root 11. If you want it to have the a in front, you can just put a 0 there to make it look like the two numbers added together. Does that make sense? Yeah? Okay. You've got 5 or 6 problems on your homework like that. All right, you ready to keep going?
You have a worksheet.
Yes, you do. No. All right. So now we're going to use what we just learned to help us find a polynomial equation. It says third degree, so that means it'll have 3 roots, which we'll talk about that tomorrow, the fact that those are connected. Or actually, not tomorrow, but in a minute. Okay, and so rational coefficients, so we're looking for whole numbers and integers, not just fractions and decimals. Anyways, it has the roots 3 and 1 plus I. What is our other missing root? Yes, who said it? We just need the 1 minus I. 3 doesn't have a conjugate because it's not a complex number, but the 1 plus I has a conjugate, and that's 1 minus I. Okay, so there are our 3 roots. Now we got to put them into factors. Okay, so we'll have 3 linear factors. So we've got 3 sets of parentheses to fill in. All of them, it'll be x minus whatever the root is. So we got all of our x minuses. Now we need to plug in our 3, our 1 plus I, and we got to put it in parentheses, and our 1 minus I in parentheses. From here, let's simplify these like double sets of parentheses a little bit and distribute this negative, make our lives a little easier. Okay, so x minus 3, it's still the same, hadn't changed. Then we have x, distribute the minus, so we'll have minus 1 minus I. What will our third set of parentheses be?
Minus 1 plus I.
X minus 1 plus I. Very good. Our next step is to distribute 2 sets of parentheses together. My suggestion is, it seems more complicated, but it actually makes it easier if you'll distribute the complicated ones first. Okay, so the ones with the I's, distribute them first. Alright, so we're going to have x minus 3, still the same. And then we're going to have x times x, which is x squared. Okay, x times negative 1. Negative 1x. X times I. Yep, just plus xi. Alright, negative 1 times x. Negative 1x, very good. Negative times negative 1. And negative 1 times I. Negative 1i. Okay, one more set. We're going to have negative 1 times, or negative I times x. So that's negative xi. Negative I times negative 1. What does that give you? Positive I, and then negative I times positive I. Negative I what? Squared. It was I times I, so we have I squared. What does I squared equal? It's imaginary, but what about when we square the I? Gives us negative 1. So this one right here equals negative 1. So what's negative times negative 1? Plus 1 down there? Okay. That's our first step of simplifying. Now let's add some like terms. X minus 3, still the same, hadn't changed. How many x squared terms do we have? Just the 1. Okay, so that one's taken care of. What about x terms?
1, 2, 2.
We have 2. When you add them together, what do you get? Negative 2x. What about xi?
2.
What happens when you add the xi's together? They cancel because we had xi minus xi. See, told you, it'll get simpler. What about the i's? They cancel as well. Negative I plus I cancel. What's left? Plus 2 from our positive ones. Now we can handle this. Okay, let's distribute again. So we get x times x squared, which is x cubed. X times negative 2x. Good. X times plus 2. Alright, negative 3 times x squared. Negative 3 times negative 2x. Good. And negative 3 times 2. Good. Combine like terms, and now we really, really are done. Okay, so how many x cubed terms do we have? Just the 1. Alright, what about x squared terms? When you add them together, what do you get? Should be negative 5x squared. Alright, what about the linear terms?
2.
And they add together to get 8x. And then minus 6 is all that's left. There's your polynomial. That polynomial has 3 roots. And those 3 roots are 3, 1 plus I, and 1 minus I. Good job. Yay. On your homework, you have 3 like these. Just 3. All right? So now this is kind of the 6.6 stuff. We're talking about the fundamental theorem of algebra, which sounds really important, right? And it's in Old English font, so it's got to be important. It really is. But the basics of this is that if you can factor a standard form polynomial of degree n into the n factors, so whatever its degree is, that's how many factors it has. That also means that whatever degree it is, that's how many zeros it has. So if you can get it into standard form and then figure out the degree, you know how many zeros it has. So this first one, is that in standard form? Is it in order, all like terms combined? Yes, it is. So what's the degree? 5. So how many zeros does it have? 5. There's your answer. Oh. Okay, this one, if you were going to put it in standard form, what would come first? X to the 10. So what's the degree?
10.
So how many roots does it have? 10. This one, what do you think? 3. If you could like write it all out, so x minus 2 happens 3 times, blah, blah, blah. You could FOIL it and all that, but you already see how many factors does it have? 3, so it has that many zeros. Now, if you got this into x equals, it would only be x equals 2, but it's a multiple 0 with multiplicity of 3. So it's the same 0 3 times, but that still counts as 3 zeros. Okay, oh no, we got 2 more. All right, is this in standard form? No, what would it be in standard form?
2p plus 2p cubed plus p cubed minus 2p.
So we have like terms, right? What are those combined? 3p cubed minus 2p equals 0. So what's the degree? And it has that many roots, right? Okay, what about this one?
2.
Ooh, y'all are good. How'd you get 2? If you move that over,